All right, everyone, welcome back. In this video, we are going to discuss basically a protocol, HSRP, that deals with routing redundancy. So let's say, for example, let's move this out of the way. Let's say this is our internet. Let's say this is let me just add a little bit of color here to kind of separate these. Okay. These devices here are our network. So router PC0 wants to talk to something on the web, which is let's say this is the router to the network internet. So it's going to go to the switch to the router as the default gateway, and then all the way to the internet, and then that's how it's going to usually travel. Let's say, for example, this router dies, right? It's gone. Now PC0 cannot talk to anything outside of the network. So a way that we can solve this problem is we'll bring another router into the network, right? Well, the PC is going to get to the network via its default gateway. And unfortunately, only one router can have a default gateway configured at any given time, unless you use routing redundancy protocols such as HSRP. And what that's going to do is basically say, hi, I'm PC0. I'm trying to talk to the network, right? The outside network. Here comes my traffic. Here comes my packet. We're going to go to router 0. Yay, we did it. But let's say this one's down. With HSRP, we can configure this as sort of like a backup router. So if this router is down, the traffic's okay, I'm coming again. And then, oh, can't go this way. I guess we can go this way. And then it still makes it to the network, the outside world. So in a nutshell, that's what HSRP does. It just acts as a backup router in case anything were to happen to your go-to router. And with HSRP, there's two different ways it can be configured. One is using a router on a stick setup. The other is using a SVI setup. And on this video, we're going to learn the router on a stick configurations. So let's go ahead and get started. We'll start off with the interfaces. So PC0 to switch 0, switch 0 to router 0, switch 0 to router 1, router 0 to router 2, and finally router 1 to router 2. And again, this is going to signify the outside network. So anything outside the network is here. We're going to focus here on this network, and this network is going to be 192.168.1.0, and we're going to give it a /24. And then we'll configure these two as networks as well. To make it simple, 10, 10, 10, 0. We'll give it a /30 since it's only router to router. We only need two IPs. 10.10.20.0/30 again. And those are going to be our networks. We'll make this .1.1. And the connections to the outside network router is going to be .2s. So let's get started. Oh, I'm sorry. We'll make HSRP IP. We'll make it .254. So the last IP of the network. And we'll make PC0.1. All right, so let's go ahead and get started with PC0. We'll configure it with a default gateway. It's going to be HSRP IP. I'm going to say 192.168.1.254, and let's configure the actual IP address of the computer. 192.168.1.1. All right, and our /24 is automatically filled. All right, let's go ahead and configure the interface from the switch to the PC. So let's go ahead and say enable conft interface f0/0. Let me see, was that f0/1? Yes, it was. Let's say interface f0/1, switch port mode access, switch port access VLAN 10, and I didn't create the VLAN on the switch yet, so we'll do that right after. Okay, good. VLAN 10 is created. VLAN 10, awesome. Interface. Oh, let's just go ahead and name it. Name. We'll just call it. I don't know. Network. There we go. All right. So exit interface VLAN 10. No, I didn't mean to do that. No interface VLAN 19. Okay, interface VLAN 10. Okay, it's up now. And we'll give it a brief description as well. This is just going to be network. Cool. Right. Alrighty. So the connection from PC0 to switch 0 is established. We'll go ahead and establish this link to the router, and then this interface to this router. Since these are going to be routers on a stick, the interfaces from switch to router is going to be configured as trunks. And since I'm going to configure both of these as trunks, we'll use interface range F0/2 through 3, and we'll say switch port mode trunk. There we go. And let's go ahead and bypass spanning tree protocol, the learning and listening portions of it. We are just going to say spanning tree port fast, do right. So that is all we have to do there. You can see these interfaces are still down. That's okay. They're down because the router interfaces are down by default. We have to configure those. So let's go ahead and do those next. We'll start off with this router. We need to say, we can say no this, enable conft interface G0/0. I'm going to say no shutdown, and you'll see this interface pop up immediately. There we go. And now we have to configure a sub interface here. So the sub interface is basically going to allow encapsulated VLAN traffic to and from this network. So let's go ahead and do that now. We'll say, and actually, we have to create the sub interface first. So in order to do that, we do interface G00. That's the interface that we were having now. And we'll use a decimal. And then I would recommend using the number of the VLAN. And this VLAN is going to be VLAN 10. Sweet. So our sub interface is created. But before we go any farther, let me just make this a little bit more simpler. VLAN 10 network. There we go. All right. So let's configure that sub interface. We'll give it an IP address of let's see, 192.168.1. We'll say 5, 255.255.255.0. Oh, I'm sorry, guys. I didn't encapsulate yet. So for the encapsulation command, we'll type enc for encapsulation. Type on push tab, and then our encapsulation method is going to be .1q, and then the name of the number of your VLAN, so 10. And now we can now add the IP address. 192.168.1.5, 255.255.255.0. Do you right? And this router should be able, well, no, not yet. We have to configure the default gateway, which means we have to configure HSRP before this router and this PC can communicate. So we can actually do that right. Let's go ahead and do the sub interfaces first, and then we'll jump to the HSRP. So let's configure gig 00, and we're going to make that interface up with one command, which is no shut. Interface G00. I'll say no shut. There we go. And then I want to make a sub interface, so I'll type in interface G0.10. There we go. And to do the encapsulation, if you ever forget, you can always push question mark. And you can see one of our options is encapsulation. You don't have to type up the whole thing, just say encap or like that. And type tab. Then we can see the other option by pushing question mark. .1q is our only option. And then we can push question mark again, and we see the VLAN ID, which is the VLAN number, which is 10. All right, so now we also have to include an IP address to this sub interface. So we'll make this .10, 255.255.255.0. Do right. All right, so sub interfaces are set up. Trunk ports are set up. Switch ports set up. We are almost there. Of course, this PC has the default gateway set as 254. Let's go ahead and get that configured. And in order to do that, we have to configure HSRP. So let's go ahead and see how we do that. So let's push question mark. HSRP is going to be configured not globally, but through the interface pointing to the network. So this is the interface we need to configure, which is where we're at. And the command is standby. You can see HSRP interface configuration commands. So we'll say standby. And then let's go ahead and see what our options are. Let's go ahead and make both our standbys version and question mark. Let's make it 2. Okay, standby question mark. Let's make our group number 1. Group numbers do have to match. If there's a mismatch, they won't communicate properly. It will not work. So let's say we want the router 0 to preempt. And that basically means this router is, I'm going to make this router a priority. And how we do that is we say priority, and the higher the number, the more of a priority it has. So the routes will go this way and ignore the other router. All right. So we have this priority set higher. Preempt means if this goes down and this router takes over, when this one comes back up, it's going to enable it so that it will become the active router again. All right. So that's all we need to do at the moment. Oh, one other thing. Standby 1. You need to include the IP address, and it's going to be the default gateway. So it's going to be this 192.168.1.254. Do right to save. All right. And from here, we should be able to ping PC0. So let's say do ping 192.168.1.1. All right, there it goes. All right. The strange thing about HSRP is we just configured HSRP as the .254. We are going to do the same thing on this router. And usually if you have two of the same IPs, here's our syslog message, HSRP is active. Usually if you have two of the same IPs on a network, you probably already have experienced it, but you get constant syslog spam where it says dupe app and then just keeps going and going and going until you turn off the interface. But this is not the case for standby HSRP, and we're going to see now. We're going to configure the same thing on this sub interface. So remember, HSRP is interface specific, pointing to the network that we are configuring. We want to make the version the same, so version 2, and standby. Remember, we need the standby 1 because that's what we configured the other router with standby. If it's standby 2, it will not. They won't communicate. We don't want preempt on this one because this is our backup router. We will make the priority lower. It should be lower by far. I think it starts off at 100, but let's just set it at 100. And let's configure that IP address. Of course, it's going to be the same. So 254. And we'll probably get a syslog message saying it's standby. So let's just, while we wait, let's ping PC0. There we go. All right, that's what we want. Now, in order for us to continue, let's configure these interfaces to the internet outside, and let's configure static routes so we can have two-way communication. So we're going to configure 0/1 and 0/1. Okay, that makes it easy. Let's go ahead and do that right now. All right, we want to say interface G 0/1, no shut, and we'll say IP address 10.10.10.1, 255.255.255.252. That one's ready. We'll do the same. This IP address, this router here. So we need to go to interface G0/1, IP address 10.10.20.1, 255.255.255.252. No shut. Do right. All right. So these two interfaces are set up. Let's go ahead and set up the interfaces on this router. So 00 and 00, I think. 01. Okay, that's no problem. So no enable conf t interface G0/0. We're gonna say no shut, and we'll say IP address 10.10.10.2, 255.255.255.2, and then we'll say do ping 10.10.10.1. Just make sure I have everything set up correctly. Cool, we do. Awesome. Now let's configure this interface here. So we'll say interface G0/1, no shut, and we'll say IP address 10.10.20.2, 255.255.255.252, and then we'll say do ping 10.10.20.1 to make sure there's connection here. There we go. We're not quite done yet though, because there is no route from the outside network to 192.168.1.0. So let's go ahead and create those routes. And we only have to create routes on this router because these networks are directly connected. So let's go ahead and say we're gonna have to make two routes, one going this way, so the next hop would be 10, 10, 10, 1, and one going this way, with the next hop being 10, 10, 21. So let's start with this route here first. Let's say, oops, I pushed the wrong button. Sorry, guys. Let's say exit IP route 192.168.1.0.255.255.255.0, and then the next hop is 10.10.10.1. And before we continue, to make HSRP work properly, we have to change the administrative distance, because if we have both of these routes, static routes set up, one going this way and one going this way, even if this router goes down, the traffic will try to split itself, because both of the administrative distances are the same. And since this is going to be a preempt HSRP router, let's make this one have the lower administrative distance. So traffic prefers this route. So let's make it 1. 1 is what it would have been default anyway, but that's just for example's sake. With administrative distance and routing protocols and static routing in general, the lower the number for administrative distance, the more of a priority it is for traffic. All right. Um, we have to do that, just because if we don't, if you ping, some of your packets will still go through, but it's like 60%, 40%. It won't ever get 100%. So let's go ahead and make our other IP route to the same network, 255.255.255.0, 10.10.20.1. So the next hop is this. And we want our administrative distance to be 111. Do right. All right, let's see what happens if I ping. Do ping 192.168.1.1. So I pinged the PC. There it goes. And if I were to use the simulation mode, it would choose this route all the time, because this one has the lower administrative distance. All right, so now to test out HSRP, I'm going to turn off each of these routers and see if I can still connect to the internet and the internet to the PC. And I will also test if preempt works. So when I turn this back on, it becomes active. So in order to do this, I guess the easiest way to do it is I'm going to use the interface range command and disable both the router interfaces. So let's see what happens. Interface range G0/0 to 1, shut. There we go. So the router is effectively not connected at the moment to the internet. We should get a syslog message saying this is active. Let's see. There we go, right here. And we should still, since we have HSRP enabled, we should still be able to connect to the internet, no problem, and vice versa. So let's see, can PC0 still talk to the internet? Let's find out. Ping 10.10.20.2. So I'm pinging this interface here connected to this router. And that's what we need. Yep, perfect. Let's just make sure there's two-way communication involved here. We will say do ping 192.168.1.1. And there we go. We're not done yet. We got to make sure this route works as well. Also, guys, I'm going to show you what the do show run looks like with sub interface and all that kind of stuff. So as you can see on router on a stick, we have our sub interface. We have it encapsulated. We had to send VLAN 10 traffic. We have a IP address on the sub interface. We have HSRP set up, and we even have another IP address It's the default gateway of VLAN 10 on standby 1. So that's what it would look like. Let's go ahead and re-enable these um, interfaces. I'm going to push Control A, and then I'm going to say no shut to reverse my shutdown of those interfaces. And pretty soon we should get a syslog message saying HSRP is active again on this router. I'm not sure how long it takes, to be honest. But while we're waiting for that to kick in, we are going to actually disable this router by just removing the interfaces at the moment. So 00 and 0/1. So same thing we did to the other router. I'll say interface range G0/0 to G0/1 shut. There we go. So this route is effectively disabled. We can see this is back to being active, so we should have no problem connecting to the internet. Let's find out. Okay, 10.10.22. I can't actually use that one anymore because, as you know, that's this interface and it shut down. It will fail. We're gonna go this way, so it's gonna be 10.2. So let's swap that out. Let's see if that works. There it goes. Let's just try it one more time, make sure. Okay, good. That's what we want to see. And let's make sure there's two-way communication. I'm hoping this ICMP will go to router 0 to switch to the PC. Let's find out. So we will say IP, oh, sorry, do ping 192.168.1.1. And there you have it. That is effectively creating redundancy amongst basically creating router redundancy. So if we have like a backup router if one goes down for any reason. Thanks for watching. In my next video, I will showcase HSRP with SVIs.